All right, let's look at nomenclature for molecular compounds. We're going to look at a couple of things here. We're going to look at molecular formulas, and we're going to look at something got mixed up here. We're going to look at special names, but I think, yep, those came out of order. Sorry about that. So we're going to look at molecular formulas. Then we're going to look mostly at the systematic nomenclature rules, and then a handful of things that have special names. So we'll look at those at the very end. Okay, so just a brief reminder, molecular formulas to describe the structure of a compound. We write the atomic symbols, and then we use subscripts to indicate the number of atoms of each element. So this first one with 1 nitrogen and 3 hydrogens, right? We would write this as NH3, right? One other thing I guess I could mention at this point, I don't have a lot of room here. We usually write the most electropositive element first and the most electronegative element last. So if the periodic table looks like this, electronegativity is something that is usually discussed late in the first semester when we're talking about periodic trends, but it actually comes up fairly often, and it's helpful to know that electronegativity increases as you move to the right and top of the periodic table, so that this part over here, this is where the most electronegative elements are. So the reason I mention that is because when we are writing formulas, we usually write the most electronegative element last. So in this one, which contains nitrogens and oxygens, if you look at the periodic table, you'll see that the oxygen is higher up, or actually further to the right than nitrogen. So oxygen is more electronegative. We'd want to write that one second. And so we would write this one as NO, and then because there are 2 oxygens, NO2. Okay. And for this phosphorus chlorine compound, chlorine is further to the right than phosphorus, so chlorine is the more electronegative element. So if we're writing the formula for this one, we write P and Cl, and there's 1 phosphorus and 5 chlorines. So we'd put a 5 there, and we'd write this one as PCl5. Okay. All right, now naming the compounds are based on the molecular formulas. So our rules are name each element. So for example, the one with the phosphorus and the chlorine, we'd name the phosphorus and the chlorine, and we put the most electropositive element first, right? Which means the one lower and to the left, and we put the more electronegative element last. That's the one that's further up and to the right. Okay. All right. Then the first element is just named as the element itself. You just use the element name. For the second element, we're going to change the ending and add an IDE suffix. So if the second element is chlorine, for example, I kind of missed there, then we change that to chloride, right? If our second element is sulfur, we change that to sulfide, right? If the second element is oxygen, we change it to oxide. All right, and then the third rule is you have to be able to indicate the number of each atom. So we've got this table here with a bunch of Greek prefixes, and these prefixes give you the number of each atom in the molecule. A lot of these are things that you're familiar with, especially over here. Well, actually, I was going to say especially on the right-hand side of the table, but really both sides. You know, a hexagon has 6 sides. Hepta, maybe you're not quite as familiar with that. 8, octa, like an octopus. Right. So these are mostly prefixes that I hope are fairly familiar to you at this point. We'll just look at the table. For 1, the prefix is mono. For 2 is di. 3 is tri. 4 is tetra. 5 is penta. And then hexa, hepta, octa. 9 is nona. And 10 is deca. Right. So for example, if we had, let's look at that one we had a little bit ago. PCl5, right? Our phosphorus is our more electropositive element, and the chlorine is our more electronegative element. So we would name this the first element, just gets its name, phosphorus, and then the chlorine is changed from chlorine to chloride, and because there are 5 of them, we'd insert the prefix penta. So we get phosphorus pentachloride. Okay, there are 2 special rules that come up. I was going to say occasionally. This first rule comes up quite a bit. You use a prefix to indicate the number of each atom in the molecule, but for the first element, if there's only 1 atom of the first element, you don't have to say mono. In fact, you shouldn't say mono. So for example, oops, I wanted to write the formula first. We'll do that. So if we had something like this, there's 1 sulfur in this, so we might be inclined to call this monosulfur. Tetrabromide. But because it's so common for molecules to have only 1 of the first element, we don't do that. We leave the mono prefix off if it applies to the first element. So instead, this would just be sulfur. Tetrabromide. Okay. You do need to include a prefix here if the number here is not 1, right? If you have 2 or 3 or 4 of that first element, then you definitely still need to include that prefix. And the second rule, which comes up a little bit less often, is when the prefix mono precedes oxide, so then one of the O's is dropped. If you left both of the O's in there, the end of the molecule, the end of the name would say monooxide, and that's just a little bit, I wouldn't say tongue twister, but it's just a little bit cumbersome, right? So for example, carbon with 1 oxygen, if we follow our rules from the previous slide, we would call this carbon monoxide. But because people don't like those 2 O's next to each other, we drop that O. And it's just called carbon monoxide. Sometimes you'll see people get rid of vowels in other places, like if you have tetraoxide, some people will say tetroxide and drop that O, but that's not really standard. It is standard to drop one of the O's when you have those 2 O's back to back in monooxide. So if you've got 1 oxygen, then it's always named this way, monoxide. Okay, let's try a couple. All right, so in this one, I'll give you a couple of compounds and you write names for them. All right, so here are a couple of compounds. We got, for two of them, we've got formulas, and then for the other two, we've got actual structures here, microscopic representations. In the one on the right, the pink atoms are oxygens and the orange ones are phosphoruses, or the red ones, I guess, are oxygens. In this one here, the pink atom is a bromine and the green ones are fluorines. Okay, all right, so look at those and write down your names, and then you can unpause it while you work on those, and then unpause and check the answers. All right, so I worked through these, and here are the names I got. For the first one, carbon disulfide, because there are two sulfurs, disulfide, and IDE, we always put that suffix on the second atom, right? This one here, we've got one sulfur and 6 fluorines, so sulfur and then hexafluoride for the fluorines. Here, one boron and 3 fluorides, so boron trifluoride, right? And in all of these cases, for the first element, we only had one atom of carbon here, one atom of sulfur here, one atom of bromine here, or boron here. So we didn't need to put mono on the front. But on this last one, instead of having one atom of the more electropositive element, the more electropositive element is phosphorus, and we have 4 of them. So we do need the prefix here. So this is tetraphosphorus, and then with these oxygens, hexaoxide. That's another example of a place where people sometimes omit those vowels because they don't like the 2 vowels next to each other. But actually, I think hexaoxide would probably be preferred. That's probably better than hexoxide. People will sometimes say that, but I think hexaoxide is actually better. So let's make that change there. All right, let's try a couple going in the other direction. All right, so here are a couple. I'm going to give you the names for these compounds, and you need to look at the names and write the formulas. Okay. Go ahead and hit the pause button, work through these, and then unpause, and we'll look at them together. Okay, so the first one is a compound of carbon and chlorine. Right? The fact that there is no prefix here means that there is 1 carbon, and tetra here means that there are 4 chlorines. So this is carbon and 4 chlorines. That's carbon tetrachloride. Okay. Nitrogen dioxide, again here, no prefix here, so that means there's just 1 nitrogen, and then dioxide means 2 oxygens, so NO2. Okay. Then dibromine pentaoxide means our more electropositive element is bromine, and we have 2 of them, and then our electronegative element is oxygen, and there are 5. And then finally, our last one, nitrogen triiodide, means we've got 1 nitrogen and 3 iodines. Okay. Once you learn the prefixes, you learn that table of prefixes, mono, di, tri, so on and so forth. These are really pretty straightforward. They're easy and actually kind of fun. All right, there are a couple of molecules that have special names, and First one, of course, is really easy, right? Water. That's a covalent compound, right? So if we followed our conventions, it would be dihydrogen monoxide. In fact, you've probably seen those things on the web where people send around a little safety warning about the dangers of dihydrogen monoxide to see if people will sign petitions to get dihydrogen monoxide banned from the food chain and things like that. But anyway, obviously we don't call it dihydrogen monoxide. It's just called water. And similar one, hydrogen peroxide is like water, but it's got two hydrogens. Right? This looks like this. All four atoms linked in a chain with the hydrogens on the end. Right? So my point here is that these are a couple of special names that you have to memorize, so that if you see that, you know that it's hydrogen peroxide, and if you see the name hydrogen peroxide, you know it's that. Also, ammonia, this is really, really common, and it doesn't follow the rules. We would have called this nitrogen trihydride, but of course that's the systematic name. We're not using that. So you should know that ammonia is NH3. And then finally methane, which is CH4. Actually, in a little bit, the last group of things we look at are going to be organic molecules, things with carbons in them. And methane is actually a part of that group, right? So we'll talk about the names of all of these alkane compounds, the ones that end with ANE. We'll talk about those as a group later on. All right, so this is a really simple topic, so her little video is fairly short. We talked about molecular formulas and being able to go from a picture, like that, and reminding you that the way this formula is written, this means that there's two hydrogen atoms and one oxygen in the molecule. Just a reminder of how to write and read molecular formulas. And then we looked at rules for systematic nomenclature of these types of compounds, right? And that was based on that table of prefixes. So you definitely need to know those prefixes: mono, di, tri, tetra, penta, hexa, hepta, so on and so forth. Make sure you commit those prefixes to memory, and then the special compounds, water, ammonia, methane, and hydrogen peroxide. Those are fairly common and they don't follow the typical rules, so make sure you're familiar with those names. All right, short video on that one. Work through some of the sample problems, and we'll be back again with another video in a little bit.